Well, my name is Tokes and Liam, and this is our podcast about, mathematics, all things engineering from Liam's perspective. Liam, go ahead and introduce yourself.
Hi, I'm Liam. I'm a 11th grade student at Dwight, best online high school in America, and I'm an engineer.
Well, you certainly are, and it is the best online. My name is Sukumar Hierman Tokes, and I am Liam's Calculus 3 teacher this year. And today we're just going to be doing a podcast about some of the things that we've learned, its applications. And one of the things that we're able to touch on this semester was neural networks. And with the advent, and actually not the advent, but with the impact of ChatGPT and many neural networks, just thought it would be interesting to talk about it from Liam's perspective. Now, we plan on doing this again next year, so it'd be nice to see how his vision or the way he thinks about these topics has grown over the year. So let me just jump straight into the first topic in neural networks, right? From what we studied in class and what you understand, how would you describe neural networks from a biological perspective to your peers?
Yeah, so neural networks are artificial systems of virtual neurons work together to accomplish a task, right? Each neuron has a set of inputs that are interpreted through a set of biases to create a single output or a set of outputs, so on. And most commonly, the neural network is fed some information that's designed to have a set output, which is known as it's a trial data set. Then the neural network takes a look at what it's answering and compares it to the desired output, and then decides, okay, these weights, which are the biases in the neurons, how they need to be shifted to accomplish the desired output. Then from this, it's actively learning how to be correct. And then you can also tweak what's correct. And then because there are so many, sorry.
No, go ahead. I'm enjoying this.
Yeah, I was gonna say, because there are so many neurons in the system, right? You got a million neurons. Imagine a beehive, right? You remove one bee and the beehive doesn't die. So you can remove a neuron, and it's gonna keep going.
So you're touching on so many things that are very interesting. Now, there are some, I would say, nuances to some of the things that you're saying, but we could touch about that later. So biases are different from weights, right? But weights are inherent, biases are weights themselves. So you're absolutely right about that one. And you're absolutely right that artificial neural networks do very good at supervised learning, which is exactly what you're talking about. In other words, there's a teacher. The training set is the teacher, and the neural network is the students, and it sort of like learns what's going to go on over there. So those are there too, but it does have some wider applications to unsupervised learning, and we'll talk about that later. We'll talk about what those means. But from your perspective, it's nice to see that. Now, my next question to you is that, given where you are in your career and your understanding of the world, which industries do you think can benefit from, learning neural networks or the applications of neural networks from what you've seen?
Yeah, so I think engineering, my favorite topic.
Okay.
The applications there are just so numerous, right? We've got a lot of it's product design. Right now, I create something in CAD and I want to visualize where my stress points are. And MIT has actually come out with a really good software called Instant CAD, where it'll tell you, it's artificial intelligence again, it'll tell you where your stress points are and it'll color code it for you. And that's just from its prior knowledge and all the training sets and all the examples. I know there are other examples. Electric cars do it really well. And you can also do predictive basket analysis through NNets, which is more of a sales and business, but engineering and business, let me reframe it.
Okay, so I think that engineering business, well, I've had paint all over my hands because I've been working all day today. So I do think that engineering and business do have very practical applications, but I think that the application of neural networks goes beyond those things. It's any situation in which you're collecting information about what's happened in the past, right, to help you predict what might be there in the future. But then it does have its bias, and every single thing, medicine has one, right? Predicting the outcome of a patient based on what's happened before. Personalized medicine is also another one, which is very, very good. But it's used a lot in business, how a customer is going to react. So basically scoring, modeling, and obviously ChatGPT and many language models use it too. And they're very good in language because language always has a structure. right? It has there's a tense in the way things go in language. But nice to see that. I want to ask you one more question though. Given you're in calculus 3, a very bright student, right? How do you think the topic of neural networks should be introduced to high school students? Or do you even think the topic of neural networks, the basis of it, right, should be introduced to students in high school?
It has to be, right? Because it's the future, no matter what. AI is going to succeed based on all indications. And in that respect, you have to know what it is to be able to deal with it in society. So yes, we have to teach high schoolers for sure, and there's a good way of teaching it. So I'd explain it through an analogy. I'd start with selecting 10 students and telling them their neurons, selecting another student as an input and another student as an output analyzer. I'd then have the input student select a noun such as social media or some other noun and ask the neuron students to give a thumbs up or thumbs down on that idea. And then from there, I would have the last student decide if there are more thumbs up or thumbs down and replicate that with a thumbs up or thumbs down. And then ask that output student to declare how confident he is in the overall answer by taking a look at the ratio of thumbs up, thumbs down. And then I'd explain how, given an input, each of the neuron students use a set of biases to decide whether a noun has a positive or negative connotation, which is then consolidated into an answer through the output student. And then I'd also mention that the output analyzer was able to determine how confident he is, which is your confidence interval. And I'd also have the students repeat the experiment using the same noun, but having one student leave to show that even though one student left, one neuron's gone from the system, because of the multi-factor parallel design of a neural network, you're fine. The output remains the same in most cases. And the system has a steady decline in performance over time. And I'd also note that although this example has a relatively meaningless purpose of determining the connotation of a noun, a neural network can be applied to more complex topics such as I mentioned before, personalized medicine, the medical field. A bunch of CAD is useful, utilizes neural networks nowadays as well. But you need to know physics, right? You need to know activation energies for neurons, right? Chemistry, similar concept, thermodynamics. Physics, chemistry, you'd want to know mathematics, probably to maybe pre-calculus, because you need to know summations. And from that, I'd explain that, hey, you've got this set of inputs, right? Big, long list. Let's think of it as a vertical matrix, right? You've got this set of weights. And the inputs and the weights the neuron uses to create a sum, which then also has another bias, a secondary bias. But then we get to this output. And you definitely, so I think physics, chemistry, and mathematics to a pre-calc level are needed to be able to understand how that neuron works, and then how the whole system of neurons working in a parallel manner functions together to accomplish a given task.
I think you're forgetting one very important topic here, one very important subject. I would say that the high school student also needs to understand
biology.
Biology. There we go.
Yeah.
See, so I think you covered everything. Yes, I think that in high school, if you have some amount of physics that you understand, right? Activation energy is one of them, right? Just to understand what energy really is, right? And then if you understand pre-calculus to summations, and I think you've nailed it. You absolutely nailed it. You don't need to understand calculus to really understand how a neural network works, because I think it can be dumbed down to, not dumbed down, but it can be reduced to a level where you say, okay, fine, we're summing all these weights and those kind of things.
Yeah,
I really do think that you can definitely teach neural networks in high school. My last question to you is, given everything that you're learning right now, and first of all, next year we're going to be doing what? We're going to be in linear algebra and Calc 4 together, right? Differential equations. And we're going to continue our topic of neural networks. My question to you right now that is, if you could skip to maybe 3 or 4 years in the future, like perhaps when you graduate college or something like that, what would you want to do with this knowledge? What job would you like to have? What would you like to be working on?
Ideally, I do want to figure out
Yes.
intergalactical travel. I'm kind of with Musk on that one. We have to start with Mars, and I definitely do think it's antimatter. So I think like I'd like to do more physics class as well as like electromagnetism, because that probably is useful for antimatter, as well
Okay.
as some of the chemistry. Because okay, I'm getting a little nerdy on this one.
No,
Photons
go
are their
for
own
it. This is your
antiparticle.
podcast.
So photons are their own antiparticles. So you can hit antimatter with photons, and it won't react to create like the most enthalpic reaction on Earth. So you can stabilize antimatter and then use that as a fuel source, and then you have the most energy dense fuel source on Earth or in the universe, as far as we know at the moment. I'm sure I'll be corrected in like 1,000 years.
Well, I mean, look, I'm a statistician, so I stay out of that, right? I stayed out of physics for a reason. But the reason I want to talk about this is because I want you to geek out on these things. I definitely want to, in more podcasts, we're going to be more of ourselves. You are yourself right now, but definitely geek out. Whether I understand the topic or not, I can talk about things in statistics that, obviously I only understand. But what's more important to me for you in high school and where we are is, as you're learning and collecting these methods and this knowledge that we have over here, what do you plan on doing with it, right?
Yeah.
And if you don't see that answer too often in too many lessons, obviously stop me, kind of switch the topic, and make sure that we take you where you want to go.
Yeah, and specifically neural networks, with regard to what I was saying earlier, is as your spaceship's going between planets or between galaxies, it's going to encounter obstacles that are abnormal and need extrapolation.
Okay.
And that's where neural networks help. It can't just be a single reactive system. It needs to know, this is an asteroid coming at me. Let's not hit that asteroid. Let's turn around it, right? It needs to know that a small deviation in angle creates a big deviation of position over time.
So what you're talking about is something that we try to do in statistics called generalization, right? You want your models or the artificial intelligence to generalize very, very well, right? That allows it to do many, many things. It allows it to have a good fault tolerance, right? Because if something is too specific, right, it tends to not have very good fault tolerance, which we'll talk about later. But yes, you are right. I do think that in space travel, there's a lot of uncertainty there. And to have a model that is comfortable with uncertainty is going to be tough to train, because
you need an uncertain data set.
You need an uncertain data set. So it'll be very interesting to see you do your intergalactic travel. I think we're over time on this podcast. I'm loving it. And
it was a banger.
It was a banger. And to the audience, stay tuned for more. All right. We're going to talk about mathematics. We're going to talk about the application of it. And we're going to talk about it from the perspective of a really bright high school student, Liam. Right. So stay tuned for more, and can't wait to give you some more.